Okay, so now we're on problem, what is it? 9.21b. All right, so how am I going to start? I'm doing x plus 2y to the third. I'm going to start with the third row, which is the one I have circled here. I'm going to write 1, 3, 3, 1. Perfect. Now, who remembers the next step? Exactly. Did you hear what she said? She said put an x and a 2y. Put an x and a 2y. X, 2y. These are the pieces of the problem. Also notice that I'm putting them in parentheses. That is absolutely essential for the 2y's, especially. Get in the habit of putting them in parentheses. The two pieces of the problem, whatever they are, in this problem, they're x and 2y. And then let's go ahead and separate those with nice big plus signs so that they don't all run together, because it's easy when we start simplifying for them to start running together. Now we need to put our powers on. Remember how that works?
3, 2, 1, 0.
So the x starts with a 3, and it counts down. And then the 2y starts with a 3 on this end and counts down. Everybody okay with that? And then we just simplify. So take a look at the first term. It's just x cubed. Because that's 1 and that's 1, so that's just x cubed. Now watch it here. This is all multiplied. You are multiplying all of this together. So that will be 6 x squared y. Is that okay? And this one's even trickier. Actually 12. And why is it 12? Because the 2 squared, remember those parentheses are essential. When you put a 2 on there, that's squaring the 2 also. When you put a 2 up here. So this is a 3, an x, and a 4y squared.
Oh my God.
So that's 12 xy squared. And what about the last one? 8y cubed. Very, very good. This is just 1, and that's 2 cubed y cubed, so 8y cubed. All right, now we're going to do a little skipping around in our notes. And we're going to go to page 59. And we're going to do a little basic probability. So we're on page 59. Number 1, Maggie and Elizabeth have bags of M&Ms. And they have counted and sorted them and come up with the proportions of the various colors in their bags. So let's see if we understand the very, very basic thing. Letter A. If a candy is chosen from Elizabeth's bag, what is the probability that it will be green? Look at Elizabeth. What's her probability it will be green? 0.2. What that chart means, kids, is that 20% of Elizabeth's M&Ms are green. 20% are yellow, 30% are red, 10% are brown, 2% or 20% are blue. So whatever the proportion is in the bag, 20%, if you reach in and grab one, that's the chance you have of getting a green one. Now, let's go to Maggie. What is the probability it will not be yellow?
2.
Not be yellow. 0.8, exactly. Because what's the probability it will be yellow? 0.2. So then all the rest is not yellow, so that would be 0.8. Good. If a candy is chosen from each bag, what is the probability they will both be red? Okay, so we're going to pick an M&M from Maggie's bag. What's the probability it will be red? 0.2. And we're going to pick one from Elizabeth's bag, and that will be 0.3. Now, what do you think I'm going to do with these two numbers? I have 0.2 for the first bag, 0.3 for the second bag. What do I do with these numbers? I multiply them. When we are doing two things at the same time, picking a jumper and picking a shirt, we multiply our options. So if my Maggie option is 0.3 and my Elizabeth option is 0.2, then my total is going to be 0.06. Watch your decimal point. Let your calculator do the work so you don't mess that up. All right, D. What is it? I'm going to pick one from each again, and I want neither to be brown. So neither are brown. So what's Maggie's not brown? 0.8. What's Elizabeth's not brown? 0.9. So my total will be 0.72. In other words, I have a 72% chance of pulling an M&M out of each bag and getting no browns. This would be no browns. If a candy is chosen from each bag, what is the probability that the first one will be green and the second one will be blue? Okay, so the first one will be green. So Maggie's first. So I'm gonna get in there and I want, what do I want here? First one will be green. So what's the probability the first one will be green? 0.3. And then I go over to Elizabeth and I get a blue one, that would be 0.2, so that's 0.06. We're almost done. If a candy is, this is F. If a candy is chosen from each bag, what is the probability that one will be blue and one will be green? Wait a minute. What's the difference between E and F?
Order.
Oh. So here we have green, blue, but here we would have blue, green. Does that make sense to everybody? I need one of each, but I don't care what order they come in. So I have to consider both. I'm going to get a green and a blue, or I'm going to get a blue and a green. All right, so let's do this first. Green, blue. Green, blue would be 0.3 times 0.2. Blue, green would be 0.1 times 0.2. So this one is 0.06 and this one is 0.02. What do I do with those two numbers? Yes, very good. I add them. So my answer is 0.08. When you have an OR situation, it's like when we were making numbers earlier and we could make 1-digit or 2-digit or 3-digit numbers. We added up the options. So whenever we have an OR, you're going to do each one individually and then add them together. Very, very good. Very good. And finally, G. G is the last one. If a candy is chosen from each bag, what is the probability that neither will be red? So we want not red and not red. 0.8, 0.7, and you're going to multiply those, right? You need them both at the same time. So the answer would be 0.56. Okay, all right. So let's do a quick minute of review. Then we have one more thing to learn on Wednesday. We'll practice a quiz and take a quiz. Oh my goodness gracious, time is running out. All right, let's how many ways can we arrange the letters of Magnus's name? What would the setup for that look like? How many ways?
Exclamation point factorial and then divided by 2 factorial.
How many letters are there? 6 factorial divided by 2 factorial because there are 2 A's. Right? Okay. Listen to this question and tell me whether it's a permutation or a combination. There are 10 kids in the group. How many ways can I award a first, second, and third place ribbon? Would it be 10 P3 or 10 C3?
C3.
I am awarding a blue ribbon, a red ribbon, and a white ribbon. If the prizes are different, it's a P. Or as James would say, you could do this one this way. That's the same thing. One more. 12 kids in the group. How many ways can I pick 5 of them to go on a field trip? Would it be 12 P5 or 12 C5?
12 C5.
C. Because if I'm picking 5 to go on the trip, it doesn't matter what order I pick them. They just are 5 to go on the trip. Okay? Ready to race out of the room, Mr. Kaufman? All right. I'll see you tomorrow. Or I'll see you in a couple days.
Yes, I did.
We have a meeting.
Yes, I'm like, she never said to me,
I guess it'll have to be Wednesday.
Okay, this is yours. What character is this?
I'm not an expert. Mr. Jensen is the one who
This
knows
is
the alphabet.
how they did it. Like, that was it, and then we did permutations exactly the same way. I think, and maybe we did put the number up there.
Are you sure it was permutations you were doing that?
It might have.
Yeah, because, oh, wait, that's to get that.
Granted, it was probably 4.
We have, did it look like this by any chance? And have a number down
Yeah.
here, like this? Okay, that's sequences and series, that adds things up, so that's a different thing. It's actually part of this chapter though, but we're not gonna get to it.
Yeah, because this is kind of in review.
Oh, good,
A little bit.
good.
Thank you.